Assalamu alaikum, beautiful class. So we're back and we're moving 5.2 now. And once again, I never figured out how to get rid of this error message that says the starboard is not connected. But let's start out. And we always start out with the definitions. Now, this is something you guys remember from previous chapters that we said many, many times. We're calling it a perpendicular bisector is what we're talking about. So a perpendicular bisector, there's two words in there. The word perpendicular means, look, if you look right here, and I'm highlighting in red. Let me highlight it in pink. It's these two lines are going to be at a 90-degree angle, and that's why it's called perpendicular. The second word is bisector. What does the word bisect mean? Well, if you take this line segment right over here, um, line segment AB, if you bisect the line segment AB, then you're going to be bisecting it exactly at the halfway point. So in this case, we label this P, which means that line segment AP is equal to line segment BP. So the perpendicular bisector bisects it right in the center, and its perpendicular is 90-degree line. So they use the word equidistance from the two figures. So AP is equidistant, and point P is equidistance from either side of A or B. So this is a fairly easy definition. It's just we're using a lot of words we used before again and again. Um, so why do we learn this again? Of course, there's going to be two theorems involved. There's a perpendicular bisector theorem. So think about this, what we just did. We have the perpendicular, we have this area line AB, and we have a perpendicular bisector, which means there's going to be a line that's going perpendicular at 90 degrees exactly. And my line's just a little off. And it's a bisector, which means this point right here that I'm highlighting in red is going to be halfway distance between A and B. So how can we use this information is what the question is saying. The first perpendicular bisector theorem is saying that if this CP, the line CP right here, is a perpendicular bisector from AP and PB, so this line right here is perpendicular bisecting, and I'm not sure why it's not drawing. Let me try this one more time. All right, there we go. That's better. What this is saying is that if we have that, then this line right here, CA, is going to be the same as BC. So these two lines are going to equal each other. Well, that's something you already know. And how do you know that? Because we've already did this in the last chapter. I'm telling you, for instance, this line here is the same as this line. So we have a side. I'm telling you this is an angle. So we have an angle. And then I'm telling you that this line on both triangles are going to be the same. So this triangle and then this triangle. That's side angle side. We know that every single angle, every single side in this is going to be the same. So side angle side is telling us that perpendicular bisector theory that this line is going to equal to this line. So fairly easy because we paid a lot of attention last chapter. We understand this material. I'm not sure how I jumped over here. Let me go all the way back. And the starboard seems to like to take its time. Okay, so we're back exactly where we left off. So now we're going to learn the converse of the perpendicular bisector theorem. This is saying that same thing, that if we have a perpendicular bisector, so we have this line right here, it has to be a line segment because remember we're bisecting it, so we have to go exactly in half. It can't be a line. If we take that and we put a perpendicular bisector, which is right here, it's going to be exactly at 90 degrees, and that turned out perfectly well. Then what we're going to say is this area, if DA, they're telling us that this line and this line are the same, then we know that this point right here is going to be on this triangle here. So what does this mean? Let's go over this again. If I started with a line segment as a point, and then I put it right in half and I do a perpendicular bisector. Now let's say I just put a line like this and I tell you it's a perpendicular, even though it doesn't look angle, but I'm telling you it's a perpendicular bisector. So this area and this area are the same. And I put a line here and I put a line here and I say, let's say for instance, this is 15 and this is 15. So let's start labeling these. A, B, C, and because this is center, let's call this line P. So if I was telling you that this line, and highlighted a. Oh, I had no idea you can even do that. If I tell you that this line is the same as this line, which I am, they're both 15, and I tell you that this is a perpendicular bisector, which makes sense because it's already at 90 degrees and it's equal on both sides. So now with this information, I can tell you that if I were to extend this line, let us see. It seems I lost this. Let me draw it one more time. All right. So if I were to, this is a perpendicular bisector. And if I had this and this, and I just said 15, 15, then I would tell you that if this was a case, and I told you it's a perpendicular bisector, this line, if extended, will go directly through this vertex right here. And that's what this theorem is telling us. So let's see if we can jump back to that slide. We're going to go back. And once again, the starboard's going to take its time. All right, so let's go back to where we were. So I'm saying with this right here, you know that this line and this are equal to each other. And you know this is a perpendicular bisector because of all the information given. So what that means at this point, line C is definitely going to be on here. We know that for sure, according to this theorem. So this is the converse of a perpendicular bisector theorem. So let's put this into action with some practice questions. Excuse me. We have right here this triangle that they label out, and we're going to get some information. And whenever you get information, I think Starboard is not cooperating with me today. All right, one more time. Let's hope Starboard doesn't do this again. All right, so this information right here. So I have this information always on my test. I want you to take all this information, write all over the test like any math class. You should be writing all over the test and scribbling and drawing everything out. So the information they gave us is this line segment, this line, exactly, sorry, BD is a perpendicular bisector to line segment AC. So we got to fill in what information that means. First, it means that these two are going to be equal. The second thing is it's perpendicular, so it's 90 degrees right there. Now the information is telling us to find AD. This information, now we already know it's 5x, but we're going to put, excuse me, we're going to put a number to it. Now, how are we going to find that out? Well, that's very simple. If you go back to our theorems right here, we said that if this is a case on here, we know that this is going to equal to this if there's a perpendicular bisector. So what happens here is the same exact thing. We know that 5x is going to equal 3x plus 14. So think about what you just said. You said 5x is equal to 3x plus 14. So all we have to do is solve this. So we're going to bring all our x's to one side using the substitute property of equality. And we're going to end up with 2x here. And over here, we're going to be left with 14. So we're going to divide this 2x by 2 to get x by itself. And of course, we had to do on both sides the division property of equality. So you end up with x equals 7. Now, did that answer the question? No, it did not. The question was asking us to solve for right here to find out what AD is. So AD is 5x. 5x, and we know that x equals 7, so we're going to plug 7 in. So now we know that AD is equal to 35, and I let the solution stay right here, so we know that it is correct. Now let me ask you this: what is going to be this line right here, CD? And if you answered it's going to be 35 also, you were correct. So let's plug this in and make sure that it works out. And it's always good to check our work whenever we have the opportunity. So let me erase all this information here so I have a little room to work with. And of course, if you have any questions or if you didn't understand anything, you can always go back. So let's plug in, where is this? 3x plus 14, and we're going to plug in the 7. So 7 plus 14. So that equals 21 plus 14, and that equals 35. So that's all for part A of this chapter. Let's go on to the next screen, next YouTube video.